A ban, sometimes called a hartley or a bit, is a logarithmic unit which measures information or entropy based on base 10 logarithms and powers of 10, rather than the powers of 2 and base 2 logarithms which define the bit. As a bit corresponds to a binary digit, so a ban is a decimal digit. A deciban is 1/10 of a ban. The name is formed from ban by the SI prefix deci. 1 ban corresponds to log 2 bit equals lane nat, or approximately 3.32 bit, or 2.30 nat. A deciban is about 0.33 bit. History. The ban and the deciban were invented by Alan Turing with I.J. Good in 1940, to measure the amount of information that could be deduced by the codebreakers at Bletchley Park using the Banburismus procedure, towards determining each day's unknown setting of the German naval Enigma cipher machine. The name was inspired by the enormous sheets of card, printed in the town of Banbury about 30 miles away, that were used in the process. Jack Good argued that the sequential summation of decibins to build up a measure of the weight of evidence in favor of a hypothesis is essentially Bayesian inference. Donald A. Gillies, however, argued the ban is, in effect, the same as Karl Popper's measure of the severity of a test. The term hartley is after Ralph Hartley, who suggested this unit in 1928. The ban predates Shannon's use of bit as a unit of information by at least 8 years, and remains in use in the early 21st century. In the international system of quantities it is replaced by the hartley usage as a unit of odds. The deciban is a particularly useful unit for log odds, notably as a measure of information in Bayes factors, odds ratios, or weights of evidence. 10 decibins corresponds to odds of 10 to 1, 20 decibins to 100 to 1 odds, etc. According to I.J. Good, a change in a weight of evidence of 1 deciban is about as finely as humans can reasonably be expected to quantify their degree of belief in a hypothesis. Odds corresponding to integer decibins can often be well approximated by simple integer ratios. These are collated below. Value to 2 decimal places, simple approximation, with more accurate approximation if simple 1 is inaccurate.